Hello, everyone. I'm Matt Marino from HeroWear, and we have an excellent panel of subject matter experts today to discuss exoskeletons. Before starting the discussion, let's meet the experts. First, we have Marty Smets, technical expert, human systems and virtual manufacturing with Ford Motor Company. Next, we have Marisol Barrero, safety manager, Toyota Motor North America. Next, we have Ryan Porto, senior ergonomist with General Motors. And last but not least, Dr. Reid is a human factors and ergonomics associate technical fellow for Boeing's Environment, Health, and Safety Organization. So I'm going to let each of you guys introduce yourself, please, starting with Marty.
Thank you very much, Matt. Really looking forward to some great dialogue today. My name is Marty Smets. I'm a technical expert at Ford Motor Company. I work in the Advanced Manufacturing Organization within the digital engineering team, and our team delivers wearable devices extended across extended reality through exoskeletons across our manufacturing global landscape.
Awesome. Sounds like great fun. Marisol, could you introduce yourself, please?
Hi, everyone. Great to be with you today. I'm Marisol Barrero with Toyota Motor North America. I'm currently the Safety Innovations Manager. And what that means is I get to scope and tinker with and trial a lot of new emerging technologies, such as exoskeletons, of course, what we're talking about today, but also things like wearable sensors, virtual reality, smart intelligent plant concepts, et cetera, to enhance our safety systems. My background is ergonomics. I'm a certified professional ergonomist, and I had that role at Toyota for about 12 years, really concentrating on ergonomics from new model to tools, et cetera. And then somewhere along the way, I discovered exoskeletons and really fell in love with them and started looking at other technologies. And actually, EWTS was really part of that evolution for me. Really attending the conference and learning from all of you in terms of all these great things out there. And I was able to fashion this into a unique new role at Toyota. So it's all very cool, new, and exciting for me. So happy to be with you today.
Awesome. Thanks, Marisol. Super interesting. Ryan, can you introduce yourself, please?
Yeah, sure. Thanks for having me, Matt. My name is Ryan Porto. I'm a technical specialist in ergonomics at General Motors. I lead the advancement of virtual human simulation for our global ergonomics team in manufacturing. And I also oversee the testing and implementation of exoskeletons and all wearable new technologies at GM.
Okay, and Chris, last but not least, can you please introduce yourself?
Yeah, no problem, Matt. So my name is Reid. As Matt said, I'm an associate technical fellow for the Boeing company within the Environment, Health, and Safety Organization. With that hat, I specify really in the area of wearable technology. So looking at exoskeletons, looking at wearable sensor technology, and also looking at different head-mounted displays like virtual reality or augmented reality. When it comes down to it, though, I also wear other hats outside of the company that are related. So with the Human Factors Ergonomics Society, I sit on the executive council as the president-elect coming in this year. I also sit with the National Safety Council, helping with the board of directors and advising them on ergonomics. And then I also work with ASTM F48, looking at exoskeleton and exosuit standards specific to the subcommittee of F48.02, which looks at human factors and ergonomics. So I chair that last subcommittee. A lot of hats, Matt.
Thanks, Chris. All right, so launching into our discussion, when many people think about exoskeletons, they imagine Iron Man or Sigourney Weaver driving a power loader and fighting aliens. The exoskeletons and exosuits of today don't really yet live up to their Hollywood sci-fi inspirations, but there are real-world exoskeletons for medical and military, first responder, occupational workers, and recreational purposes. And our focus today will be on occupational exoskeletons for workers who are performing physically demanding jobs. So these devices can be powered by batteries and motors, but most of today's occupational exoskeletons utilize springs or some other type of unpowered energy source. There are devices for the upper body, such as the shoulders or hands, lower body systems for the hips, knees, or ankles, There are devices focused on the low back, and even some full body designs that are beginning to make their way into the workplace. With so many different options out there for exoskeletons to choose from, it's important to have goals when using exotechnology. Marisol, what are some of your goals when using exoskeletons?
Hi, Matt. So at Toyota, we have about 500 shoulder exoskeletons right now across multiple facilities. And we're trialing some hand exoskeletons as well as looking at back exoskeletons and exosuits. So really most of my experience and knowledge is in the world of the passive shoulder exoskeletons. Our goal is primarily safety, make team members happier, lower discomfort, lower fatigue at work, after work. Of course, as I understand it, there's a lot of emerging evidence that exoskeletons can also encourage better quality, better efficiency, et cetera. Those would certainly be great byproducts, but it's not really the item we're looking at. We're looking at safety to not just lower injuries, but again, that lower discomfort, lower fatigue, better team member morale. And in the future, we might actually start looking at return to work possibilities as well. Right now, we have these devices only on fully healthy production team members. There has been a lot of interest from team members who are returning to work post an injury that they might be interested in using these devices. We haven't gone in that direction, but that interest is certainly there.
Thanks for sharing that, Marisol. Marty, what about you? What are some of your goals when using exoskeletons at Ford?
Right. I mean, great question, Matt. And I think that's a fundamental question that a team needs to answer before moving forward with any type of exoskeleton deployment. And for us, we're primarily we're a unionized workforce in automotive assembly at Ford Motor Company. We have over 50,000 hourly workers in North America working across our assembly plants. Like Marisol, we're building automotive, right? Trucks and SUVs. We have probably 2 or 3 lines within all our plants where the vehicles run over top in our high lines where the operators do need to work on the undercarriage of the vehicle. And it's difficult. Overhead work is a challenge, both from a biomechanical perspective and the loading on the joint level of the shoulder, and also from a postural perspective, just risk factors and having your arm mechanically in that position and what it does to your subacromial space and all the nerves and tendons that pass through it. So for us, our goal was to focus on shoulder injuries. We looked across all our medical information, and what we found was that shoulders were being injured predominantly more than some of the other joints in the body, up there with back. And then when you look at the amount of time those injuries kept workers out of work, the shoulder was a very costly and long duration injury for us. So we basically wrapped our heads around trying to tackle that. And so we were looking at passive shoulder devices, similar to what Marisol was just walking you through. So these are spring-loaded devices that support the arms when you're in overhead work. And for us, it's again to reduce the discomfort of the shoulder and reduce the amount of injuries that we see around the shoulder. And so we kicked off an 18-month research project with Virginia Tech, where we are monitoring about 100 workers, about 150 workers over that time period, 50 of which are using exoskeletons on the regular, and about 100 working overhead but without exoskeletons. And I'll share a little bit of where we're at with that study later on in the talk. But our goals were to really reduce the injuries and the discomfort around overhead work. I mean, we have a really robust upfront ergonomics process to design as much of that out as possible. But in the end, we still have a predominant high rate for shoulder injury, which gave us a great opportunity here.
Awesome. Thanks for sharing that, Marty. So when you have these goals, what are your success metrics for exoskeletons, return on investment or otherwise? How do you know when they're working to achieve those goals? Let's start with Chris, and we're actually going to do a little bit of a round robin and give everybody an opportunity to weigh in on this one.
Yeah, thanks on that, Matt. And I'm going to pick off from where Marty left off. And really, it's coming down to first starting with understanding how injuries are happening throughout the company, and then looking at it from the perspective of, could we mitigate some of those injuries, reduce them, reduce the risk around those? So some of those metrics that we look at tend to be risk metrics, tend to be injury counts if we have enough information there. In terms of return on investment, all of those add up because those add to the monetary basis for return on investment as well. But then we also look at aspects of productivity or quality. So sometimes For example, depending on the exoskeleton, depending on the nature of the work, you may have this great symbiosis between opportunity and system that leads to improvements in quality, leads to improvements in productivity. When you gather all of that information together, quality, safety, ergonomics, anything with productivity, it leads to that bottom line of return on investment. So those are some of the things we track, but ultimately as an EHS person, environment, health, and safety person, I always start with the safety. So that's just a natural leading metric for me to run by.
Thanks, Chris. What about you, Marty? Going back to you on this one, how do you know that the exoskeletons are working?
So we do a variety of different metrics, including subjective responses from operators who use them. So these are like musculoskeletal discomfort scores that we complete regularly with the operators that are using them daily. We've also done work in the lab to measure the biomechanical response to using passive shoulder devices. So EMG, electromyography on the shoulder, and other muscles surrounding the shoulder that might be involved. Or that might be maybe receiving some of the transfer load from the device, like some of the leg muscles and muscles in the lower body. But we're also looking at long-term data, so absenteeism, medical data, and this is all part of our longer-term evaluation. So there's both short-term and long-term metrics that we're evaluating, but ultimately we want to see a decrease in the amount of shoulder injuries that we're seeing in our plants over the past 4 years. So starting from about 2016 through to about 2020. We've about cut our shoulder, the days away because of shoulder injury we're about 30%. So we're about a third of what we were 4 years ago, which is a great step. And there's lots of things that can impact that, but that's ultimately what we're trying to do is reduce shoulder injuries and reduce days away because of them.
Awesome. I'm going to kick this over to Ryan now. How do you know if your exoskeletons are working for you?
I would say we're in the very early stages of trials and deployments, but just providing overhead relief to overhead jobs. They are truly one of the most difficult tasks in the vehicle assembly plant. It's not known as a high seniority job at all. Some other successes are having plants buy into the program and getting their support when using the devices is purely voluntary right now. On a personal note, just being a boots on the ground and being able to deploy some of these devices, whether it's hand or passive shoulder, just being able to work with some people with extreme shoulder fatigue or somebody with a previous injury and having them tell you how much they appreciate the device or you bringing it to them to just try it. As far as ROI or otherwise, not really focusing on that too much now, just really looking at the bringing down sprains and strains and safety issues and items like that. So
that's great. Thanks. And Marisol, last but not least from you on this one, what are the success metrics that you're looking at?
So similar to what a few other panel members mentioned, so we're looking at subjective, so ratings of perceived exertion, and of course, comfort variables from the team members. And we're also looking at some objective measures. We've done a couple of electromyography studies looking at maximum voluntary contraction of the related muscles and such. And we've gotten good impact there from exoskeletons. But really a key item that we found, and really what I call it is icing on the cake, right? So the team members feel better, but then the company is also getting good results. So we actually saw shoulder injury elimination at our Indiana plant. So our Indiana plant, kudos to them. They probably have the best exoskeleton program out of all my plants, and they've been very successful at this, and they've stuck to it for the last 3-4 years. And they selected a certain amount of processes that would get the shoulder exoskeletons based on characteristics of those processes. And once they did implement the shoulder exoskeletons, those injuries were no longer. So, and they've kept that up for 3 years now. And I presented this data for the first time at EWTS last year. And I said, hey, we're at 0 injuries and 0 workers' comp, obviously, at this plant due to the shoulder exoskeletons. And they're actually keeping that up. So in 2020, throughout this year, once again, we saw the same impact. So it's really, it's just a variety of data sources are telling us that when these items are implemented well, they can make a huge impact to the lives of team members and also to the company and profitability.
Wow, that's really amazing. Thanks for sharing that, all of you. So you all work for companies that are some of the leading early adopters of exo technology, and some of these deployments sound like they're on the larger side of things. So can you talk about what are some of the biggest challenges in managing larger scale deployments of exoskeletons? And Ryan, I'm hoping you can kick this one off for us.
Sure thing. Just speaking for automotive, being on the assembly line it's a very dynamic environment. Parts, processes, and most of all, workers are changing at a rapid pace. There's constant churn. Not only do production leaders have to deal with absenteeism, they have to deal with just the regular change of their personnel, just moving jobs and such. Due to seniority, or somebody just might want a different job because it interests them. That makes collecting long-term and objective and subjective data has been pretty limited for us. It's been a constant challenge to gain that. Had some reorganizing of plants and products. COVID, we've been delayed in getting some of that data that we want. Site-to-site differences has also been very challenging, speaking for the most part in the US. Some plants have been more open to trying exoskeletons than others. And one of the big ones is job rotation. Some plants don't rotate all the same. It may have them decide if they want to use an exo or not. Other reasons might be climate, troubleshooting, and equipment support from the suppliers, depending on where they are in the region.
Gotcha, understand. And Marty, on your side at Ford, what are some of the biggest challenges that you've run into with your larger scale deployments?
Yeah, I mean, great question. And managing deployments over several facilities across, a continent can be very, very challenging. Typically because innovation teams still tend to be relatively small at this point, typically centrally located near the headquarters, and maybe poorly represented on a plant level at this point. So if I'm looking to have a team manage, a fleet of exoskeletons in a facility at a distance from me, it can be kind of challenging. These aren't technologies that have been around a long time, so we're all trying to figure out ways logistically to store them, to clean them, to share them, to give everybody access to them, to fix them when they break. So that's definitely a challenge. Also, our manufacturing facilities are in various states of churn. If a new product is going to a facility and it's being completely gutted and rebuilt from the ground up, or if their focus is shifted on that new product, then it can be difficult to look at innovation technologies when times get really, really tight. So that's part of the difficulty is ensuring the I would say the consistency of effort at every facility because of various demands in production.
Thanks, appreciate that. So I think a lot of people may be wondering, when should a company use an exoskeleton versus using some type of automation or robotics or replacing a worker with a machine? Chris, can you talk about this a little bit from your perspective at Boeing?
Yeah, not a problem, Matt. So on one end, if we think of a spectrum, you have on one end automation, a heavy use on robotics, and on the other end, people who are traditionally in the production line. In between is this gray space where you have collaborative robotics that's kind of closing in on that human area where you have people working with robots. And then on another space is you come from the robotic side, merging towards the human side of the human worker naturally. You have exoskeletons. And so exoskeletons lend themselves obviously as potential wearable robots if you're talking about powered and semi-automated, quasi-powered systems. But really, that's the spectrum that we're at right now in terms of automation on one side, humans on the other. So now lend yourself to the workplace. You're in a situation where you're either creating a new production line or you're expanding on an existing production line to improve efficiencies. So depending on the situation at hand, you might have situations that lend themselves better to people. So for example, if you're doing a job that's highly artisan work, it requires nuances that only humans are really good at. So things that may decide on different perceptions, such as sound or sight or touch. Those perceptions are really condoned very well within the human mind, and you can adapt on the fly. It's a little harder to do that on the automation side. So robots are really good at highly redundant work, highly effective, efficient, high quality, but on the other side, not as malleable in terms of, random changes. And so that's where, depending on the nature of the work, you have to figure out which is the best suit for a hand. And exoskeletons tend to lend themselves into that in-between gray space where what happens if we upgrade a human? So you still have the mindset there, the adaptability, the artisan type qualities that naturally come to those workers. But then you also have that ruggedness, that repetitiveness that naturally beats down people and lead to cumulative trauma injuries. So it's kind of trying to find that happy space. And again, it depends on the nature of the work and the applications at hand. Hopefully that made sense.
Yeah, that's a great answer, Chris. Thank you for sharing that. So the process that you follow for identifying opportunities for exoskeletons sounds like it's a really important step, that you're identifying the right jobs, the right tasks, the right people to use these devices. Marisol, can you talk a little bit about the process that you followed at Toyota for identifying these types of opportunities for exoskeletons?
Absolutely. So we do have some optional exoskeleton usage because we want to allow these team members to try the devices even if they're not required per se for their process. But our regional standard also calls shoulder exoskeletons required PPE or personal protective equipment if the process meets certain criteria. So what that means is we have a mathematical calculation that is based off some electromyography studies that we've done both in the field and in the lab with Iowa State University that basically tells us when a process has too much overhead work where the team member performing the process is going to be at a higher risk of shoulder injury or an elevated risk of injury. So at that point, the process gets flagged for possible exoskeleton usage. That means that it's only flagged, doesn't mean we're going to require the exoskeleton. What happens next is that we look at the process and try to examine if there's any other better control to be put in place. So we don't just want to put exoskeletons on people. We don't want to put anything on people if we don't absolutely have to. So again, personal protective equipment is the lowest form of control for any type of process. So we look at engineering controls, such as an assist. We look for processing changes, such as remove a portion of the overhead work, so there isn't that much in the process. But many of the times, it's not really a feasible option to do anything else. So at that point, we then say, okay, so if you were to use the shoulder exoskeleton in the process, would you be at an increased risk of any sort of other concerns, such as entanglement, activating a light curtain when you're not supposed to, anything else that could possibly cause harm to the team member? If it all passes and it's all yay and good, then that process is designated as a required shoulder exoskeleton process. So that basically means that every team member on that process needs to wear their own shoulder exoskeleton. So it is a personal protective equipment, and that's how we use it. We give one to every single team member going through that process. And it could be more than 10 team members on process. So again, rotation, different shifts. So they really add up. But when we started out, it was really, hey, that process looks good. It looks like it could use an exoskeleton, but we've really honed that process over the years to really make it very simple, mathematical. Right now, it's just a built-in formula and an ergonomics assessment tool. So it's very simple for the plans to complete. Now, we need to continue to hone that process. This past year, we saw that really not all the processes that should have gotten exoskeletons were able to get exoskeletons because we haven't factored in all the problems. So just one quick example, we had some processes where the team member said, yes, the process is meeting all you're saying that it should meet to get an exoskeleton, but we just find it really uncomfortable to go up and down a lot because the process is really dynamic. So they're up and they're down, they're up and they're down. And it's not where you're up for a designated period of time, then you come down again. So that dynamic movement was making it uncomfortable for the team members to utilize the shoulder exoskeletons. So we're taking a step back and trying to understand what is dynamic? What does that mean, right? So they could have cumulative overhead work, but if it's too dynamic, a shoulder exoskeleton may not actually be the right solution. You don't want to cause more discomfort than you take away. So again, the point is we're continuing to hone our process to make sure that we're implementing these devices in the right places across the net.
Awesome. That makes really good sense. It sounds like you're all using really great ways to go about identifying good jobs, good candidates for these devices. So once you identify these opportunities, how do you go about introducing the exoskeleton technology to the workers? Ryan, can you start this one off for us, please?
Sure thing, Matt. At GM, first we introduce like one exo at a time to our UAW counterparts and certain health and safety teams. From there, we've actually used our National Health and Safety Conference and we'll bring in actual exo suppliers for just introduction as well as even training. And each ergonomics rep from our US plants will attend those, sometimes North American as well. So we're able to introduce it there, like North American wide. From there, I myself would travel to the plants and do a specific intro at each site, possibly with one of the suppliers. And then we'll train, again, the ergo representatives on site. Once we do that for about a week or so, we get commitment from some long-term users. We'll start to follow them with subjective surveys and keep track of how they're wearing it and follow up with them and follow up with medical screenings, make sure everything's going okay at the plant level. And that's after a few days of trialing in the plant. We'll move to the long term. I also hold like a monthly users group for all of the US plants, and they call in and we'll talk about feedback, lessons learned. A lot of it will focus on supplier updates, whether it's a cuff change, an app that comes out for a glove, strap changes, and just trying to get them up to speed with my dealings with the suppliers, and I'll roll that down to the plants. Very important as these technologies change at such a rapid pace. You want to get the end users and the trainers out there that have all the right equipment and the latest and greatest to support their users.
Awesome. Thanks for sharing that. So, Chris, I'd like to jump over to you next for this same question. How do you go about introducing exoskeletons to your workforce?
Yeah, it's pretty similar to what Ryan said and to what Marisol said. You know, we start with the application and the need, understand where the opportunity lays, and then we pair that with the right exoskeleton. So if we're talking about shoulder-related injuries or applications, we pair that with the shoulder system. Same with back systems or hand applications. Similar to what Ryan goes through, you know, we're looking at doing one system at a time. So it's a very consecutive process with going through evaluating exoskeletons, getting them qualified into the Boeing system, and then deploying them. The hard part is really on the deployment side. So a lot of the stuff that Marty mentioned earlier with regards to introducing them, going through all the operationalization of the exoskeletons is really important. And so in the end, the collaboration with the end users, that buy-in is significant. If you did your due diligence up front, a majority of the users will end up liking it and utilizing it. But ultimately, if you have the opposite effect, you have to understand what you may need to change in the system. And so understanding the usability, the usefulness, the desirability, the applicability in the area, all of those are important features without going into specifics.
Thank you. It sounds like there are a lot of ergonomics and human factors considerations when bringing new technology, especially wearable technology like exoskeletons, where we're fitting different types of people, different body types, the time it might take them to put on and take off the device. We're sharing these devices. These may all be considerations and are probably things that you've all had to think about. So can you please talk about how exoskeleton fit in particular impacts performance and outcomes Ryan, I was wondering if you could take this one, please.
Yeah, Matt, I can start that one off. I really think the first time fit is absolutely critical for the user. You really need, like I mentioned before, the latest and greatest components of the exoskeleton, and have the right support on site when I myself or different companies are fitting these things, or depending on who your support system or team is when you're fitting. So I think that's very important. This is sometimes challenging, again, like how the technology is rapidly changing to get all of the different, whether it's something that is a better strap or a better cuff or a better back support or something that supports the hip or something that cools a little better. It's been really frustrating to come back with those new items after the fact and say, did you want to try this again? It's so much better when you have it all in one with the latest stuff. We've had lots of trials that have failed even going back the second time. No, we improved this, but still don't really want to try it because of the first time it just didn't do so well for that operator. So comfort and fit adjustments are so critical, and they're so important to keep the subject wearing that exoskeletons. Sometimes we don't have the adequate support, and instructions for donning and doffing is just not as straightforward or quick enough as we'd like it to be, especially for somebody to pay attention to those. They get frustrated. They have a 60-second cycle time, and to be adjusting a strap all the time is just not something they want to be doing. So again, that fit and performance right off the bat is pretty critical in my opinion.
Yeah, that makes really good sense. It sounds like fit is a really important factor when it comes to user acceptance. So in addition to fit, what are the most important user acceptance considerations? Marty, can you take this one?
Yeah, absolutely, Matt. So we've been following a pool of operators for almost 2 years now, and along the way, we periodically ask them, we survey them on a whole bunch of different measures. And part of those things are just feedback on the device itself, which includes fit and comfort. And so we have a pretty good understanding of what the barriers are. So what are your barriers for adoption? And those are things like comfort. So people are all different shapes and sizes. And when you look back at where exoskeletons came from, really was a bunch of roboticists. What we really need is people working together with manufacturers of clothing and equipment and gear that have long history of fitting devices to people. Okay, so there's lots of prosthetics companies that are moving into the exoskeleton space as a result of this, because that's just that's a non-trivial piece of it. And you can have a team member that's really motivated to use the device, but a small chafe or irritation will get in the way of them potentially reducing hundreds of thousands of cumulative pounds of load on their shoulder over the years, as the benefits they could gain from a long-term use of a device. And certainly what we're seeing is those benefits do take a long time, over 6 months to show up. When it's interesting when we ask people's intentions after a long period of time, what they would like to do with an exoskeleton. So you've used it for a long period of time, maybe 18 months to 24 months. What are your intentions? And so some people say they would like to continue using it after the long-term study's done, and some people say they wouldn't. And when we look back at what other things worked for them and didn't work for them, we try and, what drives your intention to use an exoskeleton? We ask things like, how does it affect the performance of your job? Or, what is your general feeling about exoskeleton technology? And if we look at them individually, it doesn't really tell us all the information. So if you have positive or negative feelings about exoskeletons in general, it doesn't necessarily drive your intention to use it or not use it. So if we look at something like perceived performance, we may think, well, if they think it's making their job better or they're working at a higher quality, maybe that would also drive them to use it. But in fact, that doesn't appear to tell the whole picture or reveal the whole picture either. What we actually see is that if you have previous history of injury, that is a really strong predictor for overall intention to use in the long term, regardless of whether you feel it substantially improved or didn't improve your performance. So I think it's a really complex landscape what drives someone to decide to want to use an exoskeleton. We are still in a voluntary phase. We're a unionized workforce. There'd be a big obstacle for us to overcome to make something like that mandatory. That isn't our intention, but we do intend to identify very accurately which jobs are receiving the most benefit from these applications. And because the UAW are our partners on the deployment in general, We see long-term value there. But it's understanding those fit issues, not just in size and shape fit, but all forms of fit are critical to finding long-term uptake of exoskeletons.
Awesome. Thanks for sharing all of that. So it really sounds like the fit is important, but also it seems like exoskeletons may not work well for every single worker. So in your experience, what are some worker characteristics that tend to predict who's going to be a good fit and ultimately the most accepting of the technology? Ryan, I was wondering if you could kick this one off again.
Yep, sure. Yeah, to Marty, just to echo Marty's statement, like about just a little bit of chafing or a strap that's too tight will kind of really derail the person's dedication to the exo study or to wear it for the long term. We've also found that previous injuries and return to work cases have been some of our most enthusiastic team members. There's always increased participation and demand from them. They're also more prone to stick through the adjustment and that finding the perfect fit period. Whether it's, like I mentioned before, a new strap or just improvements in padding and things like that, they are willing to stick it out and just absolutely love when you're returning to them to try something new and improve the device. They're in it for the long haul and absolutely dedicated. So where others, it could be extremely frustrating during the initial stages.
Yeah, that makes sense. It sounds like the people that really have a strong need for it may be a good fit. Marisol, I'm wondering if you've noticed any trends as far as who's a good fit for devices and most accepting of the technology.
So when we first started out, we thought it would be the younger team members that would find the devices really cool and want to try them on. And they do want to try them on, but we find they don't want to keep them on necessarily. What we found is the more, shall I say, seasoned team members, possibly with prior injuries or older, have been at the job for 10 plus years, are more apt to accept the technology. And one other interesting point to me is that since we're using it as PPE, it seems that the team members in shops that require more PPE are ironically even more accepting. And what I mean by that is we have different shops. So assembly, they wear maybe a bump cap, steel-toed shoes, and maybe that's about it because there's not that many risks. On the other side, we have something like weld shop, where there's a lot of sharp objects. So they're wearing Kevlar sleeves, they're wearing hard hats, they're wearing safety glasses, hearing protection, etc. I almost find that the ones in weld are actually more open to trying these devices and putting more things on because they have that concept of PPE is protective. So I've got all these other things on me. Why not another one that now is going to protect my shoulder or the other body part in question? So it's interesting to see that process. But that's just a personal observation that I've made through the last few years.
That makes sense. Thanks for sharing that. A question that seems to be on a lot of people's mind has to do with the short and the long-term impacts of using exoskeletons on the end user's natural abilities, their performance, their health, and ultimately their acceptance of the technology. Marty, you had mentioned an 18-month longitudinal study earlier in the discussion. So I'm wondering if you could talk a little bit more about what you might be learning through that study.
Yeah, sure. It's still really early. So we're only looking at some of the subjective response data so far. We haven't looked at any absenteeism or the medical history at this point. But we're probably about 6 months from completing that complete data analysis. I didn't really get into the governance process that we have for rolling out and distributing exos, but we've got a governance team that in general oversees where they go and all things related to exoskeleton deployment of Ford. And so this consists of our technical experts in powertrain and vehicle operations, as well as UAW health and safety leaders from our National Joint Committee of Health and Safety. So when we're looking at this data set, we have to think about how we're going to do this in the long term. Okay, so we started off with some 3 or 4 month studies, and small 3 or 4 operator pools in 1 or 2 plants here and there, and just recorded musculoskeletal subjective information from them. In that short period of time, what we tend to see is people are very highly motivated, right? Oh, this is really exciting technology. I get, something different in my job that potentially will add value to me or help me out. People are giving me attention. Maybe I'm prone to technology and volunteered, so I'm overly enthusiastic. We tend to see very positive results in short periods of time. When we look at the history the past 24 months, so if we look at what field data is already out there, there's probably 6 or 7 field studies that have been published around passive exos, mostly around passive shoulders and passive back. The longest of which, they're all in that sort of 4 to 6 week, 4 to 8 week category. So there really isn't a lot of studies that have gone past 2 months in terms of the field data. And the problems there is that what we're seeing over the past 24 months is that it takes about 6 months for those effects to really kick in. And what we're seeing is across all our facilities in North America in general, the user group that wore exoskeletons have both lower discomfort in their shoulders and lower discomfort in their back. And there's more to talk about that later in terms of the amount and the magnitude of those changes. But if you look across all our facilities, and even when you look at them plant by plant, most plants have lower discomfort in those 2 body regions for when you compare their exoskeleton user group compared to a control group of people that work overhead all day without exoskeletons. So we do see some long-term systematic improvement in terms of at least their subjective feeling of discomfort in those body regions. The back is significant because we don't want any other discomfort in the body from carrying a load around on your torso all day. And we didn't see any increase in discomfort anywhere else in the body. Say, for example, like more discomfort in the lower body because you've been carrying around that additional mass. So we're encouraged about the long term. We do think the effects take longer than 1 to 2 months to really start coming into light. And I think it's going to get really interesting when we start looking at the absentee and medical history for that same group user population and feather in the results from our lab studies looking at the biomechanical and more objective responses. So what's happening inside the body. So that full complete data set of user response, medical history and absenteeism, as well as biomechanical measures will really paint the full picture. And we're probably still about 6 months shy from that, but I'll have probably some more data to share later this next month at ErgoX, which my colleague Chris is chairing. So tune in there too.
That's really interesting, Marty. Thanks for sharing that. And I'm sure that there's a lot of people out there that are really looking forward to the results from that study. So nice work. Another thing that comes up a lot that people have questions about are the status of industry standards for exoskeletons. These have been in progress through a few standards organizations for a number of years now. Chris, I was wondering if you could talk about where the standards are at for exoskeletons.
How much time do we have? Because we keep going. So I'll give you the fire hose opportunity. Obviously the market is very diverse. You have exoskeletons that represent industrial exoskeletons, medical exoskeletons, military exoskeletons. And so when you're looking at it from that perspective, and then we have more beyond that, we have recreational exoskeletons coming online in some places. But if you look at where medical is, for example, medical exoskeletons within the United States has been controlled by the FDA as a medical device. And so they've been looking at it from a regulatory standpoint of how do we certify a new medical device for an end user, a patient in this case. So you'll see on the regulatory side within the US, they've been leading the pack in terms of regulation of exoskeleton devices. Again, specific to medical. If we come back to where we are in industrial, the industrial exoskeletons within the US are not regulated. So what we tend to see are more leaning towards consensus standards, which is where we lead into areas like ISO or International Standards Organization or ASTM International, and looking at those consensus standards as ways to help bound some of the problems that we're starting to see, as well as improving the designs for future systems. And so when you see what's coming out on the ISO side, they've primarily been looking at it from a medical device perspective. So they have ISO 13482, which speaks to primarily medical devices with personal care robots. When we come back to the ASTM side, with F48, Frank 48 being the committee for exoskeletons and exosuits, what you see coming out of there are primarily things like terminology, things like wear, care, and maintenance. environmental conditions for utilization of exo test methods, practices, for training. So how you train exoskeleton end users, labeling and information of exoskeletons. So those are some of the upfront items. But really what it's coming down to, it's putting together practices and guides that help the end users and the manufacturers develop human-centered systems. Going back to something Marty said, we wish exoskeletons were designed by clothing providers, because then it would really fit us really well and it would move with our bodies and flow like we need them to. So, thinking with those ideas in mind, that's where exoskeleton standards are going. And eventually we'll see if they get adopted into regulation later on, at least for the industrial side of the house.
Thanks for shrinking that down, Chris. I know that there's a lot going on, especially in the ASTM and ISO worlds for standards. So I want to end this on a little bit of a fun note here, do like a quick round robin. You can answer the following question in 10 words or less. Best of luck. So Chris, I'm going to start with you. What is the future of exoskeletons?
For me, it's smart exoskeletons. The ability to bring in artificial intelligence and machine learning and then adapting it to each person. So the ability to say, today I want to use it for walking. Tomorrow I want to use it for, lifting boxes. And the system can automatically tell that, or I can change some settings and it adapts to me.
Cool. Ryan, what about you?
I think tremendous amount of potential for assembly and manufacturing, and the products are getting better. They're going to be around for a while, and I've seen the improvements within the last year. So I think it's growing at a rapid pace.
Marty, what about yourself?
I will agree with Chris. I think smart is my first word. I also have adaptive, transparent, and specific. So I think that they're going to get lighter. They're going to get more transparent to the user, more comfortable. I think that the IoT connectivity piece of it is really important as we look at how AI and machine learning can be applied to health and safety. We're essentially putting devices on people that can measure motion over time. And as you aggregate that together, there's lots of opportunity there. And specific, I think that it's still going to be, we're still a little bit far off from having really exoskeletons that are useful across a wide range of different tasks. Right now, the passive ones are focusing on a single joint level. And if we look into the powered space, mobility still is a bit of a problem. So that's where I'm at. Smart, adaptive, transparent, and specific.
Thanks, Marty. And Marisol, last but not least, what is the future of exoskeletons for you?
So I've got 10 words that I actually wrote down to keep me on track. Steady progression, softer fabrics, supporting work, mobility, and general comfort. But I'll just quickly add on that these things were born within the medical realm, and they're already progressed to work, right? So we're talking about occupational exoskeletons. They're already in the sports mobility world. So Roam Robotics has that cool knee exoskeleton. You can actually, if you're a skier, you can actually rent it at several different ski markets and ski with it on right now. Well, maybe not right now because of COVID, but next year maybe on your ski vacation. And again, they're going to keep going into the future. So I really see it as, hey, I'm going to paint my house. I'm going to paint my ceiling, and my shoulders are going to hurt a lot if I don't wear an exoskeleton. So, I see myself maybe renting one or buying one at, Lowe's or Home Depot or something along those lines, not far into the future.
Awesome, you guys. I think we share this vision that exoskeletons are here today and they're here to stay, and they're only going to get better. So I appreciate all of the information that you all have shared with the audience. And at this point, we're going to switch over to a live Q&A session.